Hey, what's up, physics? Mr. Scott here, and today's topic we are talking about colors, how you view them with light, also with pigments and dyes, technically known as additive and subtractive color mixing. We're going to try and fill out this note template so that way you can use it on your Scooby-Doo assessment. Let's go. So the first thing I need to tell you as a disclaimer is that this is not elementary school art class. The color wheel and all that stuff, it's still there, it still exists, and it's great, but we're talking about light specifically and how your eye views it. And with light, there are three primary colors that you can combine to make white light. So when we put red, green, and blue together, they're going to give us white, and you can actually go in reverse and take white light and break it down into the separate colors of the spectrum as well. So fill this in with me. Now we have red, green, and blue together, combined to make white light. Turns out that we can get the secondary colors of light by just combining two of the three primary colors. We'll get to that in a second. But what if you had no primary colors of light, or no light at all? What would that give you? And it turns out the answer is black. So without any color, you just see nothing. You just see black. And black is obviously then not on the spectrum. It's not part of Roy G. Biv. It's not a color. It is just literally a void of light. Okay, so on to the secondary colors we go, and here they are, yellow, magenta, and cyan. Let's write those in. And in order to create these secondary colors, we had to combine two primary colors. So let's try and test you a little bit here. Pause the video, see if you can fill in which two of the primary colors created each one of these secondary colors. All right, here are your correct answers. How'd you do? But yes, red, green makes yellow, red and blue makes magenta, and green and blue makes cyan. So get used to those names and also what combinations create that secondary color. So one of the main reasons why this is called additive light is because you're adding up to get to white. And it turns out when you take a primary color and a secondary color, you can find a pair that's a complementary color that allow one primary and one secondary to add to white light. And here we have three combinations, and all of them are going to add to white. So let's look at it a little closer. If you take yellow, which is red and green, and then add blue in, well, now you have all three primary colors, right? And you're going to get white light. Same thing with magenta and green. Red and blue, add in the third primary color of green, you get to white. Cyan is blue and green, and you add in the third color, red, to get to white light. But this is what we mean by additive color mixing, right? We're adding the colors together, the primaries with the secondaries, and ending up with white light, which is the combination of all three primaries. Lastly, if you're not a fan of the word explanation, how about a picture form? So here you can see all three primary color circles, and when they overlap, you get the secondaries in the inside, and when all three overlap, you get white light in the very middle. Alright, so let's transition a little bit here, and now that you know about additive color mixing, let's try and approach subtractive color mixing. And it turns out that any color of any shirt that you have, any poster board, really just anything in the world that's a physical object, is usually got pigments in it, including even your skin. And these pigments are little solid particles that can absorb certain frequencies and wavelengths of light, but then they also reflect or re-radiate other frequencies depending on the size that they are. So for example, let's think about like a white t-shirt. If you're wearing a white t-shirt in the summertime, all that sunlight is coming in with all the colors of the spectrum, and that white t-shirt is reflecting all three primary colors back to your eye, which is why you see it as white, which means that a lot of that energy from the sun that's trapped within the light is not getting absorbed by the shirt, and you're going to stay cooler. Now if you wear a black t-shirt in the summertime, it's going to absorb all three primary colors of light. Black is still the absence of light, and you're going to have none of those colors come back to your eye, which is going to make the shirt seem black. Now if it's a red t-shirt, then it's absorbing blue and green, and it's reflecting back red. So whatever you're seeing, that is what's being reflected, and then whatever colors you don't see must be what's being absorbed. Okay, so check out the diagram for subtractive color mixing and notice how it changed compared to additive color mixing. The primary and secondary colors have now flipped, and instead of having white light in the center that we're adding up to, now we're subtracting out all the colors and getting black, the absence of light, in the center. Okay, so for example, let's look at blue paint. If we're talking about blue paint, you have to create it by combining cyan paint with magenta paint. And the reason why is because the only thing that is shared between cyan and magenta paint is blue. So it will be reflected back to your eye from those pigments. But everything else is going to get subtracted out when you combine those two paints because they're not shared between both of the paints. The same would go for green paint, where cyan and yellow, the only thing that they share is green, so that's what we'd see, and everything else gets subtracted out. Same thing for red, between magenta and yellow, where red's the only thing that's shared. Now, black in the center, though, that's a different story, because there is no color that is directly shared between yellow, magenta, and cyan, which means that everything gets subtracted out, and that's why we just get black. So let's see if you've learned this, and let's try to fill out this table here of the pigments and then what colors they absorb versus what they re-emit. And I'm going to do one with you, and then I'm going to try and pause it and let you guys see if you can fill out the rest of the table. But yellow pigment is going to have to absorb the colors that it's not bringing back to your eye. So that means that it has to absorb blue, because yellow is a combination of red and green, and then it's going to re-emit that red and green back to you as yellow, and that's what we'll see with that pigment. So another Scott challenge here. Pause the video and see if you can fill out your note template, and then come back for the correct answers in a few seconds. And there they are. So hopefully you got them all right. If not, change them and try to use this for the rest of the chapter when you need it. Mr. Scott signing off. Have a good one.